All right, so this is our lesson. We're just going to be building off of it. This is the concept application. This will be on page 231, very next page, right? So this is the concept application. We're going to be applying what we learned on those prior two notes to what we're going to need to do on the STAR test or any type of test or any question that they're asking us, whether it's PIMDAS or prime factorization. Now, the next page behind this is kind of an independent practice. So I will be walking you through this one, kind of giving you steps. Make sure you're paying attention to the instructions and writing down the notes on these. Okay. So when you look at this, the first thing you're going to see is that you do see that it says, please complete the factor tree, right? And they give you a factor tree of 300, and then they give you those two branches where it's 10 times 30. Remember, factors means multiple numbers are going to multiply. Well, that 300 is our standard number. That's the number that we're starting from. So remember, I usually put a box around that just to help me memorize. That's where we're starting from. But when you're doing a factor tree, you are doing the prime factorization of 300. So you do need to know those first prime numbers. Now, those first 7, 8 prime numbers are very important. So right here, I'm going to write them. You should write them on top. But your first one is a 2, 3, 5, 7, 11, 13, 17, right? And once you memorize those 2, 3, 5, 7, 11, 13, 17, 2, 3, 5, 7, 11, 13, 17, 2, 3, 5, 17, 11, 11, 13, 17, then you can start memorizing another one, which is 19, and that would just help you be more productive. But write those on top, right? Now, our problem right here is 300, and we are going to find the prime factorization of that. And it did break it down into two numbers, which was 10 times 30. Now, when I look at those two numbers, I could look up here to see if I see 10 and 30 up here as a prime number. 10 I see is not a prime number. So since it is not a prime number, I am going to break 10 down again into two branches. Then I look at 30. 30 is not a prime number. I also know because I could find two factors of 30. So I'm going to go ahead and break that apart. 10 to equal 10, we're going to find two factors that equal 10 when we multiply them, and we should come out to 2 times 5. When I look at 2, I see that 2 is right here. That's my first prime number. So you're going to go ahead and circle that because it is a prime. When I look at the 5, I look up here. I see that 5 is a prime number. So I'm going to go ahead and circle that 5. Okay. Now, when I look over here, I have 30. I'm going to find two numbers that equal 30, and I can say 3 times 10. Again, I look at my factors number or my prime numbers up here to compare them with my factors. When I see the 3, I notice that 3 is a prime. So I'm going to go ahead and circle that 3. And since we're circling these mean that these are prime. We're not going to break branches off. And then I have a 10. So I know 10 is not up there, but I did do 10 right here. And you can see that we don't need to do the math again. When we broke 10, it is 2 times 5. So I know when I break this one down right here, it's going to be a 2 and a 5 as well. That 2 and 5, both of those numbers are prime, so I could circle those numbers. And since every branch at the end has a circle, that means we are done with our prime numbers. Now, the way that we find our answer is we have to write all of our prime numbers in order from least to greatest. So when I come here, I'm going to circle, look at all my numbers that I circle, and I'm going to write the lowest number first. The lowest number I have right here is 2. So I'm going to write that 2, and I'm going to cross out that 2 because I already wrote it. Some kids made the mistake that they only wrote 1, 2, but notice that I have another 2 down here. That is another factor, so I do need to write that other 2. So I'm going to put the other 2 there. Oh, and this is factors. These are prime factorization, so there is not actually a comma. It is actually a dot between them for multiplying. I'm going to take that 2 out. Then I have a 5, 3, 5 left. I know that 3 is the next smallest number, so I'm going to put a 3 right there, put the dot. And then I have 2 5s. So I'm going to put a 5 times a 5. Now, this is the expanded form. All right. This is when everything is stretched out, but we do like to condense those. So when you see down here, you're going to see that there's exponents on some of these, right? But just looking at this, these are called base numbers. These are all the numbers that we are multiplying. So when I expand it or when I simplify this, the first thing I'll do is I'm going to write each number that I see. So the first number that I see is a 2. So I'm going to put a 2. But I am going to put an exponent, and my exponent is going to tell me how many 2s that I have. So when I look at it, I say I have 1, 2 right here. I have 1, 2 right here. That is a total of 2 2s times that takes out that. That takes out that. Next thing I have left is a 3 times 3 put a dot, that takes out that 3. I only have 1 3, so I'm not going to put any exponents. And then my next number is a 5. And you can see that I have 1 2. So there is 2 5s up there. And that takes care of that 5 and that 5. And you're going to notice that this leaves me with a simplified answer. So it's 2 to the second power times 3 times 5 to the second power. So when I look, this one has 10 times 30, which was the first thing they did. They didn't break down anymore. So I know A is wrong. 2 to the third power means that they have 3 2s. And when I look down here, you're going to notice that I only have 2 2s. So that is not going to be here. 2 to the second power, 2 to the second power. I only had 2 2s. So far that looks right. Times 3, and then times 5 to the second power, times 5 to the second power. And you're going to see that that matches. Okay. So again, this is how you do prime factorization. This is prime factorization. You do need to memorize these prime numbers. So make sure you have those written on top, because you are going to have to do prime factorization again right here. And you're going to have to kind of remember how to do that, but you need to memorize these numbers. Okay. I'm going to erase this just so there's more room when we're doing the next part. And I probably will zoom into the question. It might be a little bit easier for y'all to see. So I'm going to go ahead and zoom in. Now, question 2, you can say the expression equivalent is equivalent to which integer, right? So this right here, you're going to see that they give us an equation. You may be able to fit this in here if you write small enough, but you may need to have to write something or somewhere else. I know there's a lot of space down here, but you need to answer this one as well. There's some space up here. But I am going to write right here. I am going to write it right here. If you write small enough, you can write it. If you're a big writer, you may need to find another spot to write it. But this says, and I'm going to rewrite the problem. It is 2 parentheses negative 57 divided by 3 plus 20 squared minus 5. Now, this is the order of operations. You're going to see that we have different operations. We have parentheses right here next to tied with a number that's stuck to it. That means to multiply. We have a negative number in there. We have some division in there. We have addition. We have an exponent up here, and we have a subtraction, right? So there's a bunch of stuff going on right here. So when I see all that stuff, I know that I'm going to need to follow PEMDAS. So right off to the sky, I'm going to write the PEMDAS. So it's please excuse my dear Aunt Sally. And remember that multiplying and dividing, they right next to each other because we're going to do those in order, whichever comes first. It doesn't matter if division comes first. It doesn't matter if multiplying comes first. When we do multiplying and dividing, we read it from the beginning of the equation down to the end. And whichever math we comes first between those two is what we're going to do. But first, we're going to solve parentheses, right? So when we go here, we're going to see that there is a set of parentheses. There is some math in it. So that's going to be our first step. When we see that, it is negative 57 divided by 3. Okay. And I do see that I have a negative number and I have a positive number. Okay. When you divide or multiply negative and positive numbers, if they're the same, doesn't matter if they're both negative, it doesn't matter if they're both positives, they're always going to be a positive answer. But when they're different, where one's a positive and one's a negative, they're opposites of each other's, it's always going to be a negative, right? Now, I know that sometimes kids get confused about that and it's confusing for them. So one thing that I used when I was learning this, I always use a strategy called Dorito Man. Whenever I had like a multiplying or dividing that had negative and positives, I would draw this little guy right here. It looks like an upside down Dorito. And he has 2 subtraction eyes and a plus mouth, right? So just I always remember the mouth is plus because you feed yourself. And his name was Dorito Man, D M, right? And I call him Dorito Man because that D did not really stand for Dorito, it stand for division, and that M did not really stand for man. It was multiplication. But Dorito Man just helps me memorize the 2 letters and what it's mean for. Because whenever we have negatives and positive, we're going to use this guy for division and multiplying only. We're not going to use it for adding, subtracting, but for division and multiplying, we will use him. So I see that this 57 is a negative. So I'm going to get to scratch out this negative right here. I see that this 3 is a positive. So I can scratch out this positive right here. And when I look at this, I see the last thing I have left is a negative sign. So I know whatever I have as an answer between this will be a negative because that was the thing that was missing. You can also see that one number is a negative, one number is a positive. Those 2 numbers are different. So that means that my answer is going to be a negative. Now we have a 57 divided by 3. I'm going to write it over here on the side. If you want to write it over here on the side, you want to grab, like I said, grab another sheet of paper, fit it right here. But it is 57 divided by 3. 3 goes into 5 one time, minus 3, because 1 times 3 is 3. 5 minus 3 is 2. Bring down the 7. Now, how many times does 3 go into 7? You have 3, 6, 9, 12, 15, 18, 21, 24, 27. So it goes in 9 times. 9 times 3 is 27. And that's what we'll be subtracting. So my answer was 19. So that part was negative 19. And I'm going to keep that in parentheses because that equation was in parentheses. Now everything on the outside of the parentheses on this side is going to bring brought down. And I'm going to show you what I mean. So like this 2 is on the outside of that parentheses, that 2 comes down. And then on the outside of the parentheses on this side was all of this. So all that's going to come down, the plus sign, the 20 squared, and the minus 5. Now I look and I'm going to check if I have any parentheses. I do have parentheses, but there is no math inside of there. It's just a number holder. So that means that the parentheses is done. The next step is exponents. Now, when I look at this, exponents are those little numbers on top like that. I see that I have 1 right here. Now, remember, when you see an exponent, that exponent is telling us how many times I'm going to write that base number. So since I have a 20 to the second power, that means I'm going to have 2 20s. So I'm going to have a 20 times a 20. Okay, that's what that means right there. Now, when you have this 20 times 20, you can see 0 times 0, 0, 0 times 0, 0, 2 times 2 is 0, right? So when you have zeros at the end, just multiply your 2 whole numbers, right? Like 0 and 0, that's fine. 2 times 2 is 4. I have 2 zeros, and I'm just going to bring those 2 zeros out, right? So 20 times 20 is 400. So that 400 is going to go right under here. I'm going to write that in red so you can see where I'm bringing it down, right? That part right here is going to go down to 400. And then I bring everything else down, right? So after the 20 to the second power, I had a minus 5. Before I had a plus, and then I had the parentheses with the negative 19 in it, and then I had the 2 on the outside. I'm going to check to see if I'm done with exponents. So I look at the top of each number. I notice that none of these have exponents, so I am done with the E. Now, this is the part where it says multiplying the blind, dividing left to right. I know dividing was in here, but that division sign was inside the parentheses. That's why we did it first. This time, we're going to go across to see if there's just any multiplying dividing. Now, I don't see any multiplication dots and I don't see any division signs, but we do have to remember that when a parenthesis is stuck with a number on the outside and there's no math symbol between them, there's an invisible multiplication dot right there. Okay, so this actually means 2 times negative 19. All right. Now, if you look at that written, it is actually going to be written as negative 19 times 2, right? You're going to see the same thing like the division man, right? We have a negative, and a positive. That 19 is a negative. That 2 is a positive. So my answer is still going to be a negative. One number is a negative, one number is a positive. They're opposite signs. That means that's going to be a negative answer. 19 times 2 is 37, 38. My bad. Let me rewrite that. So it'll be a negative 38. That takes care of that 2. That takes care of that negative 19. Now, I'm not going to write that number in parentheses because I already solved it, right? I used it over here. It does not need to be a number placement holder. And I also see that I'm going to bring down a number sign. So the operation sign is going to come down to plus 400 minus 5. Now I'm going to go again, see if I have any more multiplying, dividing. I have a negative sign, a plus, and a negative. So I know there's no multiplying. I know there's no dividing. So now add and subtract is the same thing. I'm going to start from the beginning. I'm going to work my way down. I'm going to do the first come, first up from the beginning to end. So the first thing I see I have a negative 38 plus 400, right? Now this is where those math rules come in, right? Like we have to be able to memorize those rules from adding integers. And we did that a couple of weeks ago. Now, the rule is it's kind of similar to multiplying, right? If the numbers are the same, it's a positive. right? Same number, same signs are positive, which looks like this. Different signs are negatives, which looks like that, right? Same signs, different signs. It's the same thing here. This is a negative, this is a positive. Those are different signs. So I'm going to subtract. I'm going to subtract those two numbers. And I'm just going to subtract like I normally would. 38 is first, doesn't mean I'm going to write 38 up here, right? I just know those are opposites. So I'm going to subtract them. I'm going to put it just like I would in elementary. 400 minus 38. My bad, I grabbed the screen on accident, right? So you can't take 8 away from 0. You have to borrow over, put that at 10. Still need to borrow over, so I'm going to turn that 10 into a 9, and that turns to a 10 over here. Now 10 minus 8 is 2. 9 minus 3 is 6. 3 minus nothing is 3. So that right here comes out to 362. And then I bring down the minus 5. And now you're going to see that that is the last part we have. 362 minus 5. You will borrow over. That will become a 12. 12 minus 5 is 7. 5 minus nothing is 5. And 3 minus nothing is 3. So you're going to see that we got an answer of 357. Okay. So you notice, yeah, the space right here is small. You will need to write smaller. If you cannot write smaller, you're going to have to find another scratch paper, write it on there and staple it to this. Okay. So I'm going to go ahead and erase this, and then we're going to move on to the next question. Now, the next question is number 3. This is kind of like more of like a word problem, but pay attention to what it's really asking you to do, right? So when I see this, this question says, as Thomas was checking his homework, he found a mistake in simplifying the expression as shown. He found a mistake in simplifying the expression as shown. Each step in the process should represent an expression equivalent to the original problem. Which step shows the error that he found, right? So it says to simplify this problem. And when I look at this, you can see that there is a minus sign, a plus sign. We have a parentheses, we have an exponent, we have a division sign. So this is a PEMDAS problem, right? So I'm going to write PEMDAS. So please excuse my dear Aunt Sally. And I'm not going to really solve this, but I do have to be able to figure out where they messed up. This right here is the original problem. They want you to simplify that. Okay. So when I look at this, I'm going to say that the first step that this person should have taken, or as Thomas should have taken, or the paper he was checking, he should have done parentheses first. So I see that there's a parentheses right here. And inside the parentheses, I have two things. I have an exponent and I have a division sign. Okay. You still have to follow the PEMDAS rule here. I still have to go, what would I do first? Would I do the exponent first, or would I do the division first? When I look at this and I go down the line, you're going to see that I have to do that exponent first. So I'm looking inside this parentheses and I have to do that exponent. This exponent says that it's 0.8 as a base to the second power. That means that 0.8, I'm going to have two of them. So I'm going to put 0.8 times 0.8 because there's two of them and I have to multiply them together. So you can see that it is division with the decimal. I'm just going to multiply it. 8 times 8 is 64. 8 times 0 is 0 plus 6 is 6. And then I'm going to see that I have a decimal here with one digit behind it. I have a decimal here with one digit behind it. There was one jump here. There was one jump here. That was a total of 2 jumps, meaning I have to jump back in 2 times. 1, 2. So my answer was 0.64. And when I look at this, they look like they turned that 0.8 squared to a 0.16, which means he just did 8 times 2. That was an incorrect step. So we noticed that this right here is the area that they messed up on step 1. Okay. You will have to be able to figure out these steps like this. Sometimes you don't have to solve it. You just got to find out where they messed up at. And right here at the beginning, they messed up, and you're going to see that they continue working that problem. That was a lot of wasted time. Okay. That's why it's very important to understand the rules of PEMDAS. Go ahead and write that down. Pause the video. I'm going to go ahead and erase it and move on. Y'all could go ahead and pause it and write anything y'all need to write down. Okay, so now when I go up here to the top, you're gonna see that question 4 says Diego found the prime factorization of each number shown below. So there's 4 numbers at prime factorization. Which prime factorization does not correctly represent the number shown? So there's 2 ways we could do this, right? First, you need to know all your prime numbers. 2, 3, 5, 7, 11, 13, 17. So I am not going to do prime factorization on all 4 of those numbers. If I'm looking for one that is not correct and they give them to me, I need to first know my prime numbers. And the first thing I'm going to check is which one of these does not have a prime in it. So if I'm looking at this one, 2, 3, and 5. Well, 2, 3, and 5 are primes. Okay, that looks good. 2, 5. All right, 2 and a 5 are prime. That's good. 2 and a 5 is a prime. That's good. 2, 5, 11. 2, 5, 11. All right. So they're all primes. Now, I am not going to break down 90. Okay. And I'm not going to then break down 402. That's a lot of work. But because that's a lot of, you have to think of the factors. But they did give me the answer for each one. And remember, it's telling you that we're just multiplying all those numbers and it should equal that. So I am actually going to test them, right? The first one I'm going to do is 90. And they said 90 was 2 times 3 squared, 2 times 3 squared times 5. So I'm going to do each one. I know that I see 3 squared here. That 3 squared right there, that equals 3 times 3. So 3 squared, 3 times 3 is 9. I'm going to replace that 9. I'm going to bring a dot, dot. I'm going to bring down that 5. I'm going to bring down that 2. And now I have 2 times 9 times 5. And you just do it in order. 2 times 9, that is 18. Bring down the times 5. And then 18 times 5. 18 times 5. 8 times 5 is 40. 5 times 1 is 5. Plus 4 is 90. And you're going to see that it matched up. So 90 was correct. And we're going to scratch it out because we're looking for which one is not correct. Okay. And I'm going to do each one in a different color just so we don't get mixed up. Then the next one is, I'll do the next one, which is right here is 250. So 250, I'm just writing a number so I know what I'm doing, is 2 times 5 to the second power, or third power, actually. Hold on, let me erase that before I mix up. See, I double checked my answer with that and notice that I wrote a 2 and it accidentally said a 3. So we have to make sure we're writing the right numbers. So 2 times 5 to the third power. Now, when I see 5 to the third power, that is saying I have 3 5s. So I'm going to I'm going to rewrite it. I'm going to have the 2, which is the same. And then I'm going to see that I have 3 5s, 5 to the third power. So I have 1 5, 2 5s, 3 5s, and they all have a multiplication dot between them. Then I'm just going to multiply like I normally would. And I'm going to do like 2 numbers at a time. I'm not going to try to skip. So the first 2 I'm going to do is 5 times 2, which is 10. And then I'm going to bring the other 2 5s down. So times 5 times 5. Then I'm going to do 10 times 5. 10 times 5 is 50. And then I'm going to bring down what's left over, which is the times 5 on the end over this side. And then I have 50 times 5. And you might need to write this one out. 50 times 5. 5 times 0 is 0. 5 times 5 is 25. So this was 250. As you can see, it did match up. So I know that 250 is correct. And again, we are looking for the one that is not correct. The next one is 400. So now with 400, you can do the same thing. You're going to see that 400 says 2 to the third power times 5 to the second power. So I'm going to write this one up here. And it says 2 to the third power times 5 to the second power. And that's supposed to be a dot. So I'm going to rewrite this. This one is my base number is a 2. My exponent is a 3. This one says 2 to the third power, meaning there are 3 2s. So I'm going to write 1, 2, 2, and 3. And then 5 to the second power, meaning that 5 is my base, saying I have 2 5s. So I'm going to write 1 and 2. Now this is my expanded form. I just have to multiply it, right? I am working backwards from prime factorization. So I'm going to say 2 times 2 is 4. And then I'm gonna bring all this other stuff down. I use the first two, so times 2 times 5 times 5, right? I bring in all this down right here. 4 times 2 is 8. Then I'm gonna bring the rest down. So I'm gonna bring that times 5 times 5. 8 times 5 is 40. Then I'm gonna bring that last times 5 down. And then 40 times 5. 40 times 5. 5 times 0 is 0. 5 times 4 is 20. And you're gonna see that is 200. But you're gonna see that my answer should have been what? Right? So I'm gonna put a dot here. I'm pretty sure this is the answer. But sometimes we make mistakes, just like over here when I accidentally put a 2 instead of that 3 up here. So I'm going to check that 110 because it's only 3 numbers. It's already in expanded form. I'm just gonna try it out to see how it solves. And then if I get it, if it's correct, then I know that 400 is my answer. So I'm gonna try 110, right? And it says that 110 should have been 2 times 5 times 11. I'm gonna go 2 numbers at a time. So 2 times 5 is 10. Then I'm gonna bring down that times 11. And then 10 times 11 is 110. And you're gonna see that 110 matches with that 110, which means it was correct. And we're looking for the one that is not correct. So that could be my answer. And the only one that was incorrect was C. Okay, so this is how you work backwards from prime factorization, right? First thing you want to do is make sure that all the numbers that are in the answer choices are in prime. That's why I wrote the prime numbers again right here. Why it's important to know your prime numbers. And then I just wrote the problem, wrote it out in expanded form and solved it. Wrote the problem, wrote out in expanded form, solved it. Wrote the problem, wrote it in expanded form, solved it. Wrote the problem. It was already in expanded form and then solved it. Okay. So this is working backwards from prime factorization. Now the last one, right? I'm going to erase all this. If you need to pause it, go ahead and pause it. If not, continue and we're going to go ahead and listen and solve this last question. Now this one says, what is the value of the expression 25 minus 6.25 plus 5 times 3 to the second power? And it says, write your answer in the space above. So I know I have no space to work right there. So I'm going to rewrite it over here. 25 minus 6.25 parentheses plus 5 times 3 parentheses to the second power. Now you're going to see I have an exponent, I have some parentheses, I have a multiplication dot, I have a subtraction sign, I have addition sign. It's a bunch of stuff in here, bunch of different type of math. And since we have a bunch of different type of math, we do need to know the order on do this. And that is when we call the order of operations, which is PEMDAS. And it's please excuse my dear Aunt Sally. The first thing we're going to do is parentheses. Notice I have 2 sets of parentheses. I have a parenthesis here, I have a parenthesis here. When you do parentheses and there's multiple ones, just do it from the beginning to the end, right? So the first thing I'm going to do is on this one is I am just going to work this first one, right? That's my first parenthesis I see. That's the first thing I'm going to work. And it says 25 minus 6.25. So that's like saying $25. Because if it's a decimal and this doesn't have a decimal, then I'm going to read it like money. And if that's $25, I'm going to write this like $25. So I'm going to write 25 with a decimal and I'm going to put those zeros. Now, the reason why I did that is because this number has a decimal. That's a 6.25 or 6 and 25 hundredths. That has a decimal. And since I'm subtracting, it needs to look easy. And on subtraction and addition, that decimal lines straight up. And now I'm going to put $6.25, right? Or 6 and 25 hundredths. The math in there is subtraction. So we're going to go ahead and subtract that. 0, take away 5. I cannot take 5 away from 0. So I do need to borrow over. You could tell I cannot borrow over from this one. So I have to borrow over from one more. I'm going to take 10 from this. That's going to switch that to a 4. That's going to switch that to a 10. I still need to get all the way over here. So that 10 is going to borrow over. That's going to become a 9. And then this one's going to become a 10. Now 10 minus 5 is 5. 9 minus 2 is 7. That decimal in addition, we don't count them out. In addition and subtraction, it looks simple and easy. It goes in a straight line. 4 minus 6, well, I cannot take 6 away from 4, so I do need to borrow over. That 2 is going to become a 1, and that 4 is going to become a 14. Now 14 minus 6 is going to be 8. And then that one minus nothing is one. So my answer was 18 and 75 hundred. Oh, wait, 18 and 75 hundredths. And that was just for this part, 18 and 75 hundredths. Notice that I do have another parentheses, but I am just going to write everything out. I'm not going to try to skip steps. I'm not going to try to do two things at once. I did that parentheses. I'm still on P. I haven't crossed it out because I see another set of parentheses. So I have to do that other set. On this side of the parentheses, it does say 5 times 3. 5 times 3 is 15. I am going to keep it in there because I see an exponent on the outside. Now, the reason why I'm not doing that exponent first, because that exponent is not inside these parentheses. Notice over here, we did that exponent first because that exponent was inside the parentheses. It was part of this problem. This exponent on the outside, this is just say, hey, I'm here for later. Okay. So I'm going to write that exponent on the outside. And then I'm going to bring that plus sign down and then that 18.75. I'm going to scoot that over a little bit. 18.75 and the plus sign. Okay. So now I check it again. P for parentheses. Yes, there's parentheses, but there's no math inside of it. It's just a number holder. So that's going to be done. E for exponents. And this is where I see that exponent. Now that exponent is on the 15 and it is a square. It's a 2. That does not mean 15 times 2. That is telling me that there's two 15s. So that is actually 15 times 15. Now 5 times 5 is 25. 5 times 1 is 5 plus 2 is 7. I'm starting on my second number, meaning I got to start one space over. So I put one placeholder. 1 times 5 is 5. 1 times 1 is 1. 5 plus 0 is 5. 7 plus 5 is 12. 1 plus 1 is 2. So this is 225. And that's for the exponent and the parentheses. So now everything else comes down, the plus sign and then the 18.75. Now this says $18.75 because that decimal that's right there plus 225. Now notice that again, this has a decimal, this does not have a decimal. So I'm going to write it like numbers, our money. That says $225, $225 because I want a decimal in it. Plus $18.75. Again, I'm going to put the decimal to line up because of this addition. And I'm going to put $18.75. Notice how all these numbers are lined up. I'm making my math look easy. And we're adding 0 plus 5 is 5. 0 plus 7 is 7. Decimal falls straight down. 5 plus 8 is 13. 2 plus 1 is 3. Plus 1 more is 4. And then 2 plus nothing is 2. So now my answer out of all of it, working all the way down, is 243.75. All right. So make sure that you pay attention. If you're confused on any parts, I do recommend you to watch it again. I do recommend you to write the notes again if you have to, because tomorrow or the next time we do this, you will have to answer some of these questions on your own. Okay. Tomorrow is more, the next time we do this, it is more of an independent practice. All right, guys. Thanks and have a great day.